Okay, a large part of 14 through 17 is related to those exponent charts and your knowledge of your exponent rules. So I want you to think of this separately, and it will just help to kind of move it off to the side for now, and we'll come back to it. So even if you want to kind of cover it up for right now, we want to focus on this radical right here, and we want to be thinking of our powers of 5. So your 2 to the 5th, 32, 3 to the 5th, which I don't even know if we made you go up that high, but 3 to the 5th, 243. And I think that's as high as we had you guys go. But you want to think of, okay, which one will break up the 128? Well, 243 is already too high, so we know we're going to use the 32. And you want to ask yourself, well, 32 times what? And if you're not sure, what you can do is take 128 divided by 32. So we get 4, which means 4 times 32 is 128. Make sure you're putting the 5th root back on these. Now when you're thinking of 15 and 27, you want to say, okay, I need a number that's divisible by 5, but doesn't go over the number we're looking at. So if you're thinking about 27, you don't want to think of 30, you want to think of the number 25. And what you're going to do is you're going to take the power, so in this case 15 is the power, the exponent, divided by the index. Well, 15 divided by 5 works out nicely. I get 3. So a to the 3rd is going to move out to the outside, and we won't have any left over. So because 27 doesn't divide by 5, we want to think of the 25. Power over index. 25 over 5 is 5. So on the outside we have b to the 5th. But if you're thinking about it now, we really were supposed to do 27, meaning there's 2 left over. So the leftovers are going to stay underneath that radical. 25 and 27, the difference is 2. We can also simplify this 5th root of 32, and so that was the whole goal of thinking of our powers of 5. This one was too big. So what we can do now is make this into plain old 2. And then we would just want to clean it up a little bit. So we're going to say 2 times 2 is 4. Our exponents will get added, so this will become a to the 4th, b to the 7th, and then our leftovers will just come down with us. So 4, b to the 2nd, don't forget about that index of 5, and this is my final answer. So this is the same problem. We're going to just not even think about this that's on the outside. We want to think of our perfect cubes. So if I think of 2 to the 3rd, that's 8. 3 to the 3rd, 27. And 4 to the 3rd is already too big. So 27 or 8, which one will break up the 54? We want to think of 27. So we're going to say the cubed root of 27. And then 27, to get back to 54, I'd have to multiply it with 2. 27 times 2 is 54. Okay, so these exponents. 6 nicely divides by 3. 10 doesn't though, so you want to think of the number 9. 13 also doesn't divide by 3, so the closest to it that will divide by 3 without going over is 12. Alright, so now we want to say, okay, 6 divided by 3 is 2. So on the outside now I have a to the 2nd with nothing left over. 9 divided by 3, if you want you can write that above here, is 3. So I'm going to take out b to the 3rd. And 12 divided by 3, I'm going to take out c to the 4th. But I have some leftovers here, so it wasn't actually a 9, it was a 10. So underneath my cube root house, I'm going to have 1 left over, the difference between 9 and 10.
Please come to door 1. Kayla Kozanecki, please come to door 1.
And then the difference between 13 and 12, so there's also 1 left over here, so that's c to the 1st. All right, so we're going to kind of clean this up a little bit. We still need to simplify the cubed root of 27, which is 3. So we're going to say negative 4 times 3. This is all multiplication in between. Negative 12. We're going to add our exponents. So this is a to the first and a to the second. So that makes a to the third. B to the first and b to the third make b to the fourth. C to the fourth doesn't have anything to combine with. We've got our cubed root and all of the remainders underneath. So big 2, BC. If any point you want to go back and rewind, maybe erase your work or take out a blank piece of paper so you can practice it again. Okay, but you want to make your list of all of the powers that match the index. So these are cubed roots, so we want to think of our powers of 3. 2 to the third, 3 to the third, 4 to the third. So that's 8, 27, and 64. So we're already kind of getting up too high. So we can see that the 8 will break up the 72. We'll say 8 times 9 is 72. When we do the next one, we want to bring down that 5 as our coefficient. But 40 will also use 8, and 40 is the same as 8 times 5. Okay, when I go to do the last one, we want to make sure we bring down our negative 7 on the outside, and again 32, so we're going to say 8 times 4. So when I simplify this, cubed root of 8 is 2, so we say 2 cubed root of 9 plus, now this is a 2 from the cubed root of 8, but I have 5 times 2 now, which is 10. Bring down your cubed root of 5. Okay, so again, cubed root of 8 is plain old 2, and negative 7 times 2 will give us negative 14 on the outside. Bring down the cubed root of 4. Now all of these are none of them are like terms, so this is our final answer. If these radicals were the same, let's say they were both the cubed root of 4, then I would combine their coefficients. Now when we don't see the index, it's an index of 2, so our powers of 2. We can say the square root of 4 times the square root of 2. That middle one, bring down the 5 as your coefficient. How do you break up 27? I'm going to say 9 times 3 because 9 is a perfect square. And the last one, bring down your 2 as your coefficient. When you're thinking of 32, don't think of 8. 8 is a perfect cube. We want to think of perfect squares. So 16 times 2. 16 is a perfect square. And then the perfect squares are going to get simplified. So this will be 2 root 2. This is just a plain old 3 now with the 5, so we're going to say plus 15, bring down that square root of 3. This is now negative 2 times plain old 4, so that's negative 8, bring down your square root of 2. So these are called like terms. We're going to combine those. We'll say negative 6, we're just adding their coefficients. The root 2 will still stay root 2. And then the 15 root 3. And that's our final answer.